Welcome to today's class. Like I promised, we are going to look at application of percentage to real life situation. So the first thing we are going to look at is discount. Okay. Now, discount has two types of questions that we can ask you. We can ask you to find the new amount, okay, after a discount, or we can ask you to find the discount amount. What we mean by discount amount is that we can ask you to find the amount that's going to be removed from the original price. Okay, but let's look at this question and see the type of question on discount that is given to us. He said that a toy is tagged 1,500 naira, but you can get it with a discount of 5% on weekend sales. What will be the price on the weekend sales? Okay, so this question now, we are looking for a price after discount. Okay, now remember, discount, like I said, is an application of percentage. What type of percentage? Increase and decrease of what? Percentage. That's percentage increase and decrease. That's what we apply in discount. Okay. In discount, we are reducing, so that's decrease. Now, what do we normally do? We first of all find the factor or the multiplying factor, okay, for the amount that will give us the price. Remember how we normally get the multiplying factor, which is going to be 1 minus the percentage. So this is our multiplying factor. Why is it 1 minus the percentage? Because it's discount. So the price tends to do what? To reduce. So if you do that, that will give us the new amount A2 equals to A1 times the Okay, so this is what we have. So with this now, we can say that the new amount, which is A2, is equals to 1,500 times 1 minus the percentage discount, which is 5%. Okay, 1 minus 5%, what would that give us? We come here and do that. 5% is the same thing with 0.05. 1 minus 0.05 will give us 0.95. So we have 1500 times 0.95. That will give us 1425. Therefore, the price on weekend sale is 1,425 naira. Okay, so this is the price on weekend sale after they have deducted 5% from the actual price. So our second question on discount, we are asked to find the percentage discount of an item tagged $250 but sold at a discount price of $225. So this one, all you need to still do is use your percentage increase and percentage decrease. But using the multiplicative factor, okay, of the percentage to solve this will not be a good idea. So we can just use our traditional method of solving percentage increase and decrease. So we say that percentage discount will give us 250 minus 225 all over 22 250 times 100 over 1. So that will give us, this here will give us 25 over 250 times 100 over 1. So this and this will go. Then we'll have this. So that will give us 10%. Now you'll be wondering why I have 250 here. Yes, because 250 is the original price. That's the actual price. So this is the new price. Okay. So it will not make this one to be at the denominator. No. Percentage discount for this item that have moved from this price to this price is 10%. So let us look at one more example on discounts. The next question we have on discount is that we are not trying to find the percentage, neither are we trying to find the new amount of the shoe. We are trying to find the actual amount that will be removed from the original amount. Okay, so if you are giving me 12% discount, what is the amount? What is this 12% going to amount to that you're actually going to remove from the price of this shoe? So that's what they are asking us here. They say that if a 12% discount is tagged on a shoe of $1,200. What is the discount amount? What is that amount we are going to remove? Let's solve that. So this way, this one now, we are not going to solve it like the way we have been solving. So we just say that the discount amount is equal to 1200 times 12%. That will give us 1200 times 12 over 100. This and this will go, this and this will go. So we have 144. Therefore, $144 is the discount amount. Okay, so what does that mean? If I move to this shop to buy this particular item, okay, they are actually going to remove $144 for me, okay, because there is a 12% discount on that particular item. So that's how to solve that particular problem. So under profit and loss, most problem under profit and loss is actually related to percentage increase and decrease. Okay, so the way you solve your percentage decrease and decrease, that's the same way we solve questions on profit and loss. Of course, just like when we solve discounts now, you notice what happened. Though discount is only negative, only decrease, only percentage decrease, but in profit and loss, we can have uh, percentage increase. We can also have percentage decrease, depending whether it's profit or loss. Okay, so in this question is a profit that we are making. So this Mr. John bought a car at $5,200 and sold it at a profit of 15%. What amount was the car sold? Okay, so we need to just find the new amount, just the same way what we have been doing. Our A2 equals to A1 times 1 plus our percentage increase. Okay, now remember why is plus, because profit is percentage increase while loss is percentage decrease. So that will give us 5,200 times 1 plus 15%. Okay, that will give us 5,200 times 1 plus 15% will give us 1.15. So that will give us 5980. Therefore, the amount the car was sold is $5,980. Okay, so that's how to solve that. You can see I keep using this. It's one of the easiest and shortest method of solving any problem that involve percentage increase or decrease. Okay, so let us move to application or the third application of percentage in real life situation. So the next application of percentage is simple interest. Okay, now simple interest, we have a formula that we use, but that does not mean that you cannot solve that problem or any problem in simple interest without even using the formula. You can actually do that. Okay, so but let's stick with the formula. We have the formula of simple interest as simple interest equals to PRT over 100. Okay, and I always add the second formula, which you might not see more often in the textbook. So I call it that A equals to P plus I. So what is my XI? Or okay, let's use I here. So what is my I? I is the interest. Um, P is the principal. R is the rate. T is the time. And A is the amount. Okay. Now, let me explain that. Interest is the extra, the added money, okay, that you will get after a certain number of years. The principal is the actual money that you put in. Okay, so the initial, just like what I've been serving as the initial amount. Then the rate is the percentage increase. Okay, what is going to be the percentage increase on this investment or this amount that you are putting in? Then the time is the duration. Of course, we know that. Then the amount, very important, because most times this is what they will ask you, the amount. Okay. And when you just know this formula, most people, what they know is just this formula, this I equals to PRT over 100. Now when they ask them for the amount, they actually don't know how to go about that. Okay, the amount is the total money you will get after investment in a particular number of years. Okay, or if you are the one borrowing, how much you are going to pay back at the end of the agreeable time for the loan. So let's solve a problem that involves simple interest. This first question we are going to solve on simple interest is very simple. So let's see how we can solve that. He said that Jenny invested $200 at 7% uh, per year simple interest for 10 years. Calculate the amount she will get at the end of the 10 years. Okay. Now, in this question, they are not just asking you what is her interest after 10 years. They are asking you the amount she will get. Of course, when she's getting her money, she will get both the interest and the amount that she invested. So let's solve that. So P here is equals to 200. I, we don't know it. T is equals to 10 years and R equals to 7%. Okay. So using all these to put in here to get our I, we have that I equals to 200 times 10 times 7 over 100. With this and this will go. So we have 140. Okay. So 140 is going to be her interest. Therefore, the amount is equal to uh, the money she put in, which is 200 plus the interest, which is 140. So she will get $340 at the end of the 10 years of the investment. Okay, so let's solve one more problem on simple interest before moving to compound interest. So the second question we have on simple interest is about them asking you to find the rate. Okay, this is the amount the person borrowed, this is the amount the person is going to return. Okay, so this is the time, but we don't have the rate. So what are we going to do? We have the amount that the person returned, which is 145,000, and amount the person borrowed is 100,000. Okay, so with this, we can find our A, imply that A equals to P plus I, therefore I equals to A minus P. So which will give us 145,000 minus 100,000. So that will give us 45,000. So 45,000 is the interest. So with that now, we can imply that I equals to PRT over 100. So with that, we have 45,000. 45,000 equals to 100,000 times R, we don't know it, times 10 all over 100. So this. So I have that 45,000 equals to 10,000 times R. Divide both sides by 10,000. 10,000. This will go. So we have R as 4.5%. Okay, so that's the interest rate, okay, given to Jude in that particular transaction. Okay, so let us look at compound interest. So in compound interest, we make use of this, okay, but remember, if you have been with us on this particular topic in compound percentage, we make use of a formula like this. I would have put plus or minus, but in compound interest there will not be any minus, because interest means there is an addition of a certain amount from your investment or whatever. So this and this are the same, it's just different parameters that are used. Here we have A2 equals to A1 times 1 plus the percentage raised to power n. Here we have A equals to P into 1 plus R over 100. R over 100 is the rate, which is the percentage, then raised to power n. Okay, Remember, A is the amount, P is the what? Is the principal. Please, this thing you are seeing here is not I, that's 1, okay? That's 1 plus, just like we have 1 plus the percentage, okay? So let us solve example on compound interest and see how that looks like. So we have a problem that on compound interest, they ask us to calculate the amount for $5,000 at 8% compound interest per annum for 2 years. Now, in this question, I will solve this problem with the formula. I will also solve it without the formula so that you can see how you can actually solve without formula. So let's solve with formula here. So solution A is equals to P. P is 5,000 into 1 plus the percentage, which is 8%, which is 8 over 100 into 2. So that will give us 5,000 into, if you calculate this will give you 1.08 square. So when you use your calculator to press this value here, you will get $5,832. Okay, so this is what this amount will get or will be after 2 years at 8% compound interest. Okay, now let us solve this without formula and see how or whether it's difficult, whether it's easier. So we'll find out. So if you are solving without the formula, you have to indicate the year, first year, second year, like that. Okay, so first year, what is going to be our interest after first year? That will give us 5,000 times 1, because that's 1 year now, just first year, times 8% all over 100. This will go, so we have 400. So our amount after first year will give us P plus I, which is equals to 5,000 times 400. That will give us 5,400. So this is the amount in the first year, at the end of the first year. So when it comes to second year, the second year, this amount at the end of the first year will now become our principal at the end of the what? At the beginning of the second year. So let's call this one I1. I2 now will give us 5,400 times. Remember, we are calculating yearly, so that's 1 times the rate over 100. So this will go. So that will give us 432. Okay, therefore the amount after second year will give us 5,400 plus 432. That will give us 5,832. So you can see the process that it took us to get our answer, and using the formula we have our answer. So whichever method that is convenient for you, you can use that to solve. Remember, you can ask you can be asked to find the interest. So if I'm using the formula and I'm asked to find the interest, what am I going to do? I have gotten my amount. All I need to do is my amount minus my principal. That will give me my interest. For this one, if I'm asked to find my interest, all I need to do is to calculate the first year interest and the second year interest and add them together. That will give me my total interest. Remember, you can be given something like this without the rate, and you'll be asked to find the rate. You can also be given uh, without time or without the number of years. You can also be asked to find the number of years. All you need to do is to put your formula, find your n using the formula, and you find your n. Now, before we move to another application of percentage, let me say something on compound interest. So, like we already know that A equals to P into 1 plus R over 100 n, and we normally say that this n is number of years. It's not necessarily need to be number of years, okay? Now, if we are asked to find the amount after 5 years, okay, after 5 years, and we are given the percentage interest, okay, we are giving the percentage interest, of course, in compound interest, let's say 0.5 0.5% per month. So what are we going to do? All we need to do, please, this must be in the percentage that is given to us, okay, or the rate given to us. All we need to do is to find the number of months that will give us 5 years, okay. So I think we have about 60 months in 5 years. So if I'm calculating this, I will now have my n as 60, okay, because the rate given to me is in per month. If the rate given to me is in per week, remember that we have 52 weeks in 1 year. So if we are asking the amount after 4 years, I have to change that number of years in weeks, because the rate given to me is per week. Okay, maybe let me solve one question on that so that we can be able to use it to relate to what I'm saying. So we are going to use this example to show what I just said now. So in this question, Alex invests her $350 at a rate of 0.25% per month compound interest. Calculate the amount Alex has at the end of 5 years. Now, in this question, you can notice that the interest is in this question, you can notice that the interest is in months, okay? And we are asked to find in 5 years. So the first thing I will need to do is to say that 12 months equals to 1 year. Therefore, 5 years will give us this times 5, 12 times 5, which is equals to 60 months. Okay, so using the formula that we have been using to solve, the amount equals to P, which is 350, into 1 plus the rate, which is 0.25 over 100, into 60. So that will give us 350 into, this will give us 0.5, 0.25 over 100. That will give us 0.0025. So plus 1, that will give us 1.0025 raised to power 60. Okay, let's rewrite that. That will give us 350 into 1 plus 0.0025 raised to power 60, which will give us 350 into 1.0025 into 60. So that will give us, okay, 406.56. Now they ask us to the nearest dollar. Therefore, the amount is $407. Okay, so this is the amount at the end of 5 years. Okay, so you can see the way we have solved that. We changed the months, the years given to us to months because the interest is in months. Okay, in depreciation is almost like compound interest. The only difference with depreciation and compound interest, there are two differences anyway. One is that depreciation, the value decreases, while compound interest, we expect the percentage to be increasing. Okay. Then another thing is that in depreciation, we don't have, we must not have a certain percentage. What I mean is that it's not necessarily to be 5% for every year. It can be 15% for the first year, then the subsequent years will be 8%. But in compound interest, there is a constant percentage. Okay, so it's going to be a constant percent. Now, how are we going to solve? In depreciation, we can solve it with the other method that we have used to solve compound interest, which is taking it year by year. Okay, so let us solve one example and see how that goes. Look at a problem we have under depreciation. It said that if the value of a car depreciated by 15% after the first year and 10% in the subsequent years, find the value of a car worth $15,000. Oh, sorry, worth $5,000 after 3 years. Now, how are we going to solve? First of all, the first year, okay, Of course, remember depreciation is like a percentage decrease. So the first year, the amount A2, so we are going to use our A2 equals to A1 into 1 minus our percentage. Okay, so this is what we are going to be using. Minus because it's going to be, is always, depreciation is always percentage decrease, while appreciation is percentage increase. So we have minus here. So our A2, okay, let's call it our A1, that's amount after 1 year, is going to be 5,000, which is the amount of the car, into 1 minus the percentage, okay, for after 1 year. So that will give us 5,000 into 1 minus 15% is the same thing with 0.15. So that will give us 5,000 into 1 minus 0.15 will give us 0.85. So that will give us 4,250. So after 1 year, the worth of the car is 4,250. Now we can do second year, third year, or we can now use the method we use in compound interest. Since the subsequent years is a constant percentage decrease, okay, we can actually use raised to power 2 now. But let us continue with this method. So for the second year, our A2 is going to be, this is the worth of the car after first year. So that will give us 4,250 into 1 minus, is now 10%, it's no longer 15%, so we have 10%. So that will give us 4,250. If you use your calculator here, you have, this will give you 0.1. So 1 minus 0.1 will give you 0.9. So when you multiply, you will get 3,825. Then for the third year, we have A3 equals to 3,825 into 1 minus 10%. So that will give us 3,825 into 0.9, 442.5. You can now conclude, therefore, the car worth $3,442.5. Okay, so you can see the way we have solved that problem. So let's go over it again. The first year is 15%, and we have 1 minus 15%, because this percentage decrease. Okay, so if you have been following us on this topic, we established this thing together. Okay, you remember where we used this for the first time, so we have been using it since that time. So if you solve that, you will get this value. Then you also have to solve for the second year. It's no longer 15% decrease, it's now 10% decrease, because they say 10% for the subsequent years. So 10% here will give us this, 10% here will give us this. Okay, so after 3 years, the car will no longer be worth $5,000, rather it will now be worth $3,442.5. Okay, so this is where we are going to end our class on application of percentage. Please, please subscribe and share our videos and give us a thumbs up. See you in the next class.